Hello, everyone, and welcome to the INAF workshop on carbon reduction opportunities for cold chain. It is my honor to be your chair today. My name is Judith Hansen. I'm the director of Europe for the Global Cold Chain Alliance, which is an association representing third-party temperature-controlled logistics, playing an essential role in the food chain, but not only. It's everything related to logistics for any kind of goods or item that requires temperature control. So that also includes pharmaceutical produce or any other parts requiring temperature monitoring. Thank you very much to the organizers for inviting me to be the chair today and giving me this opportunity. Carbon footprint reduction is very high on GCCA's agenda, obviously, because we are part of the cold chain, and it's a high energy demanding industry, and obviously we have our part of responsibility in reducing carbon footprint. So it was only natural for us to take part in this exercise. I'm also part of the advisory board of the INAF initiative to take an active role on behalf of the association in the reduction strategies for the future. We will have a panel of experts today talking about the issues, the challenges, and the opportunities. So I would like to kick off and invite Kristina Norne Widell from the Sintef Ocean to open this session.
Yes, now I think you can see my screen.
We can indeed.
Yes, very good. Okay, good afternoon, everyone, and thank you for the opportunity to present at this workshop. I will introduce you to our project INAF, European Food Chain Supply to Reduce Greenhouse Gas Emissions by 2050. I will start with some background. Food systems are globally responsible for quite some share of the total greenhouse gas emissions, and there are several challenges that need to be solved. Over the whole food chain, approximately 60% of food is refrigerated at some part, and it is estimated that approximately 70% of emissions from food are related to perishable foods. And this is what we are going to work with within INAF. A very important challenge is, of course, to reduce the emissions. The main source of emissions is related to energy use within the food chain, but it has been estimated that this can be reduced with up to 50% by several different initiatives. Examples are reducing load, optimization of processes, and integration. Another important source of emissions is loss of refrigerants, especially if they have high global warming potential, which many still have. The food industry has always made efforts to reduce energy consumption, and the challenge is that much of this reduction has been through relatively simple improvements. So a further reduction of energy consumption and emissions will not be as simple and will also require advanced technologies and significant changes to operational practices. Another challenge is that the food sector is highly diverse, and it consists of many different enterprises, where the majority are small to medium-sized enterprises. Benchmarking and assessing current emissions of all these is a challenge, but also communicating information and providing right technology to them. So that's where the INAF project comes in. The project will provide technologies, tools, and methods to contribute to the EU farm-to-fork strategy to achieve climate-neutral food businesses. The project started in October and will last for 4 years. It receives funding from European Union's Horizon 2020 Research and Innovation Programme. The goals of INAF is in line with the goals of the EU farm-to-fork, and they are to identify how the food industry can reduce emissions by 50% by 2050 compared with 1990 levels. Also to identify how we will achieve climate neutrality for food businesses and improve the overall integrated sustainability of food systems, while at the same time meeting societal goals. And of course, also increase awareness among policymakers, businesses, investors, entrepreneurs, institutions, stakeholders, and citizens. In our project, we will work with the challenges in the food sector related to greenhouse gas emissions and suggest many solutions. Emissions related to post-farm gate or post-harvest are the focus of this project, and these are estimated to account for about 20% of total emissions. Emissions from food production, processing, packaging, transportation, storage, retail display, catering, and home consumption will be assessed as separate groups to identify where the greatest potential for emission reduction is and where mitigation actions can be applied. So we will develop, adapt, and apply new technologies, but also better integrate and streamline processes. This is particularly the case where heating and cooling can be integrated, and available new energy sources, for example, photovoltaic, wind, and geothermal, can be fully integrated into the industrial processes together with thermal and energy storage. Within the project, we will demonstrate technologies to show industry and other stakeholders their feasibility and reliability. The project team has extensive and strong links with industry groups, and this enables us to communicate information actively and effectively. A particular focus of the projects will be on thermal integration to utilize waste heat resources that are currently rarely utilized effectively. Sometimes it also could also include waste coal. Information will be integrated from a food system perspective using a unique IoT-based analysis platform, combining sensors and databases with digital twins in the food chains, from processing to consumption, considering the impacts on energy use, emissions, quality and safety, and food waste. Although the project has technological focus, it will also focus on non-technological and behavioral issues, because technologies need to integrate into processes and be accepted by end users. Additionally, adaptations or changes to the food chains themselves may also have significant benefits in reducing emissions. Examples are, for example, the use of home deliverable, shorter and more compact food chain, and better integration between the sectors of the food chain. Although this slide is quite detailed, I will not stay very long on this page, but it's merely to give you an overview of the project. The project is organized in 11 different work packages who will tackle different perspectives of the challenges. Since all of these issues are closely connected, the work packages are closely linked and requires communication in between. I will now give you some more information about the work package 6, the demonstration of best technologies. An essential part of the project is to demonstrate promising technologies and best practices to reduce the environmental footprint of the food supply chain. The demonstrators will set good examples of the solutions we find in and along with the project. They will show actions to reduce emissions, which are from simple solutions to the most advanced. The project includes demonstrators within mainly 4 specific product categories. See them here: meat, fish, dairy, fruit, and vegetable. Along the food cold chain, which is process, storage, transport, retail, and domestic. The demonstrators show potential and results on energy saving measures, and the technology and methods should be transferable to other industries, other companies, and other sectors. So we have pre-selected 14 demonstrators which are within the dark gray areas of this table. During the project, we will include at least 6 more demonstrators. So we have invited all partners to send proposals so that we will cover more of the areas shown here. So far, the project has 28 partners, and it is coordinated by me and Sintef Ocean in Trondheim. The partners are from 12 European countries. They are universities, research institutes, industry, and international organizations. So thank you very much for your attention, and please have a look at our newly launched webpage, enoughemissions.eu. Thank you.
Thank you, Kristina, very much for this insightful presentation and this ambitious project. I would like to now call Mr. Alan Foster from the LSBU on mapping emissions from the UK refrigerated food cold chain. Alan, over to you.
Right, hello everyone. I'm just going to share my screen. Okay, hopefully, I'm in the wrong place. You can all see that okay?
We can, Alan.
Yeah, okay, thank you. Hi, thanks everyone. Apologies to everyone who came into my presentation earlier and saw my virtual twin. This is going to be a very similar presentation, but this time you get it live. So it's mapping emissions from the UK refrigerated food cold chain. So this was work done just on the UK because it was part of a previous project, the UKIRK SCC project. But this work is going to feed into the Enough project and be expanded up. So a summary, food and drink industry is the largest manufacturing sector in the UK. Agri-food sector is £120 billion and 9.4% of gross value added. The cold chain is energy intensive, but also obviously F-gases create a lot of fugitive emissions as well. And the aim of this work was to benchmark the food refrigeration emissions in the UK. As I said, this is a UK centric piece of work at the moment. So we were looking at food and beverage that's consumed by humans in the UK and the direct emissions, so fugitive emissions from F-gas leakages, and the indirect emissions from power stations used to power the electricity for the refrigeration systems, and only the emissions within the UK border. For the direct emissions, or scope 1 emissions as they're now called, we use the UK greenhouse gas inventory, and where there were gaps, some reports by SKM and VIROS. For the indirect or scope 2 emissions, we use the Digest of UK Energy Systems, also SKM and VIROS reports, climate change agreements and levies, and UK government reports. We split the cold chain into a number of different sectors. Agricultural and fisheries, so this is just post-harvest. So it's refrigeration, for example, on the farm. So that could be refrigeration in milk and things like that. Food and drink production, so that's the processing of the food before it goes out. And then it goes to cold storage. This is after production and before sale. So it's the large cold stores, not smaller cold stores within retail facilities, etc. Then retail, so that's really supermarkets all the way from large supermarkets down to the small supermarkets. Food service, this covers anywhere where food is prepared and given out for people to eat. So cafes, also restaurants, health service, schools, etc. Transport refrigeration. This is refrigeration between the different sectors, but not including domestic transport. And it's only the emissions associated from the refrigeration or the transport refrigeration unit, not in terms of the moving of the vehicle. And then finally, domestic refrigeration, which is obviously refrigeration in the home. So these are the results we got. So the direct emissions, or scope 1 emissions. Agricultural and fisheries, you can see it's very small. As I said, it's only there's not a lot of refrigeration on the farm. The main one is probably milk. Milk is refrigerated on the farm, and some vegetables are refrigerated on the farm, but not much more than that. Food and drink production, obviously, getting a lot more here because you're actually having to take heat out of the product. So you've got large refrigeration systems, all with F-gases in them. Cold storage, this is very small, considering much smaller than food and drink production. The reason for this is that most big warehouses use ammonia as their refrigerant, and ammonia's got a GWP of 0, so it doesn't cause CO2 emissions when it leaks. Transport refrigeration, I must say in here that in this bit here for the Scope 1 emissions, I haven't included the fuel used to power the refrigeration system. This is only the emissions of the refrigerants or the fugitive emissions. That comes out as 0.69. This is quite high because transport refrigeration does tend to use high GWP gases, and they do tend to leak a lot because obviously it's a moving vehicle with a lot of vibrations. Retail, this is really the big one. About half of all of the direct emissions come from retail, 3 megatons of CO2 per year. Must also say that this is changing rapidly. So, yeah, so basically because supermarkets are moving over to CO2, the amount of emissions from retail is dropping quite rapidly. So where we are on this reducing curve is difficult to say. Food service is quite low. There's a lot of pieces of equipment out there, but they're factory-made units. They don't tend to leak like retail systems, and they tend to be more likely to have hydrocarbons in as well. And domestic is 0.15, which is very low. Once again, almost all hydrocarbons are 600A for domestic fridges. Very few high GWP gases, and when it does leak, it's a very small amount. So the indirect emissions, Scope 2 emissions, so this comes from the electricity effectively. Agriculture and fishery is still small. Food and drink production is going in the direction you'd expect. That what generally tends to happen is the further you move down the chain, the energy consumption causing the emissions increases. Transport refrigeration here is actually, I've got the fuel used to power the transport vehicles. When I've got two values, green and red, it's because I've got a number of sources and I'm using the minimum and maximum from the sources I've got to give an idea of the uncertainty. So transport refrigeration is quite a difficult one to evaluate because it's difficult to know how much of the diesel that powers a transport refrigeration unit and how much goes into the vehicle itself. So there's a lot of assumptions here. It's quite difficult to get an exact value, but as you can see, it's pretty high. Retail, once again, pretty high, 1.5, but surprisingly not high in comparison, for example, to food service. Food service here, I've got a very big range, and it's a very difficult one to determine because food service is so diverse. There's so many cafes and canteens, etc. It's lots of different pieces of equipment in there. It's difficult to know how much equipment is there and how much energy it's using. I'm currently doing more work on this to try and get better values, and I've come up with more recent values up in terms of above 2 megatons. So I think it could be higher than what we've got here, just because it's a difficult one to determine. Domestic here comes out as the maximum, 2.37. And that's because there are just lots of domestic fridges and the number of them swamps anything else. So the conclusions from this work are that more than half the direct emissions are from food retail, and half of that are from chilled centralized cabinets. What I showed in the previous presentation this morning was actually I split the emissions in terms of the different pieces of equipment, but I didn't really have time to do that in this presentation. And from that, you could see that from the direct emissions, it was mainly the the cabinets that you can see a picture of on the right, it's chilled retail display cabinets, so the big one, effectively. And also, the majority of indirect emissions are for domestic fridges. And once again, I haven't shown it in this slide, but it was in the previous presentation, that more than half of that are from fridge freezers. And that's really because most people have fridge freezers in their home. So more than half of the fridges in people's home are fridge freezers. So it adds up to a great amount of energy consumption or emissions. So the next step in this work is to look at all food-related emissions. This was just refrigeration. So we're extending it to gas for heating and cooking, and even heating and ventilation systems as well in kitchens, etc. And also to expand it from the UK to the EU. So we're looking at the emissions in the whole of the EU. And then finally, trying to project this baseline to 2050. So that baseline that you looked at was approximately 2019, 2020. And we're already doing work. I've done work in the UK looking at some of these things, projecting forwards. And that's it. Thank you very much.
Thank you, Alan. Thank you so much for all these market data. Very interesting indeed. I'd like to call now Mrs. Yosr Allouche from the International Institute of Refrigeration, who will talk about mapping emissions from the European food chain.
Yes, hello everyone. Thank you, Julie. This is Yosr Allouche speaking from the International Institute of Refrigeration. Slide 2, please. Yes, so today I'm going to present some figures about the emissions from the European food chain sector, which were found to be online with those found by Alan for UK. Slide 4, please. Next. Yeah. Okay, so the agri-food system is generally accounting for the same activities, but they are generally labeled and classified differently depending on the investigating organization. But in general, these are referring to the three main categories as land use change, farm gate, all those activities coming at farm level, and post-farm gate, or more commonly called as the food supply chain. In the supply chain, we can, or we are looking at enough at those or at these sectors shown here to the right hand side. This is the enough illustration made for the visual identity of the project, containing the different steps of post-farm gate, which are processing, packaging, transport, storage, retail, food service and consumer. And as mentioned, enough will be looking at tools and methods for these sectors to achieve climate neutral food business by 2050. Next, please. I'm here presenting figures about global emissions from agri-food sector using data from the FAO database, where it was reported that although the global anthropogenic emissions from agri-food system, they have increased by 16% from 1990 to 2090, probably due to the development of the cold chain or in the refrigeration equipment, and also the extensive land and farm use. These shares, or their shares in the total emissions, they have decreased from 40% to 31%. So it can be seen from that pie, from this pie to the left hand side using the FAO data, that farm gate is the largest emitting category with 13%, then the post-farm gate with 11%, and then the land use change activities with 7%. Now looking to the right-hand side, to the Sankey chart, and specifically to the global post-farm gate zone surrounded, the main greenhouse gas emissions contributors are found to be as the methane from the waste disposal, including the solid food waste, domestic, industrial, water use waste, and incineration, and also from CO2, CO2 from the fossil fuel combustion, mainly in household, retail, and transport. Next, please. So these pies, they are giving the emissions share of the different food sector categories, where it can be clearly seen that in high income countries, specifically in Europe, you can look at those or at that orange square. Supply chain or post-farm gate is the largest emitting category with about 54% share in 2015. While generally in low and middle income countries, you can look at these at that green square to the down. Emissions are mainly originated from farm gate and land use change. Next, please. Now looking at the European food emission bars, when comparing emission statistics between 1990 and 2090, the tendency in Europe is found to be opposite to that in other industrialized countries. Even if it's decreasing slightly from 2.3 to 2 gigaton CO2 equivalent, probably to the increased concern of Europe in developing clean and efficient cooling solutions supported by the EU F-gas regulation. Although these emissions have decreased, but their shares in the total emissions, they have increased by 8% from 23 to 31% in 2090. It should be also stated that in Europe, emissions at farm gate were dominating in Europe in 1990. As you can see, those larger yellow colored parts of 1990 bar, while those at post-farm gate are dominating in 2019, looking at those larger blue part of 2019 bar. So looking at post-farm gate, these emissions are mainly originated from food loss occurring from farm to retail sector, from the refrigeration equipment, and from food waste at the consumption sector. Next, please. Okay, I'm here presenting figures to the left about food loss using the FAO data for 2017. So looking at those blue bars, you can see that about 20% of food loss is lost in low-income countries, which are generally associated to the lack of refrigeration equipment. While in Europe, shown by the green bars, where the refrigeration equipment exists, data shows that about half of the food produced needs to be refrigerated, and from that amount, about 87% are being actually refrigerated and resulting in food loss low to 7%, mainly consisting of fruit and vegetables, as you can see in the colored right-hand side histograms. So this larger gap in losses can be attributed to the unequal distribution of the refrigeration equipment. So in the world, as you can see, using the GCCA data for 2017, so these are indicating that the refrigerated warehouses capacity per urban resident in the world, and where you can see that in Europe is considered as largely covered. Next, please. So now when it comes to emissions from cold chain equipment for various regions in the world, looking at the histogram, it can be seen that Eastern Asia, Europe, and North America alone are responsible for about 73% of these emissions. And from the map, it can be seen that in Europe, most of the emissions are located in Western and Southern Europe, where the European food production and handling is known to be most occurring. It should be also stated that low emissions in northern countries, which are generally related to somehow to the larger use of natural refrigerant and renewable energy sources to run the business. Next, please. CO2 emissions from the European cold chain are also given per sector, where it can be seen from the bars that the major contributors in Europe are retail and refrigeration transport. And only the two of them are contributing with about 74% of CO2 emissions. Also looking at the yellow part of the retail bar compared to the other yellow parts, retail is responsible for the majority of direct emissions related to the refrigerant leakage. Regarding to the domestic sector, this is the third ranked largest emitting sector, and the cold chain contributing with up to 15% of the emissions, mostly related to the energy consumption, so indirect emissions. Here, it's also important to state that those calculated emissions and the domestic sector, they are only counting for emissions from the refrigeration equipment and still not including the food waste and food disposal that we will be looking at during enough. So looking at the pie, approximately 74% of the food sector emissions are indirect, from fossil fuel combustion to run refrigeration equipment, while 26% are direct emission originating from the refrigerant leakage, mainly in the retail sector. Next, please. As concluding remarks, post-farm gate is the largest emitting category in Europe currently. Retail and transport are the largest emission contributors to the cold chain. Still looking at the cold chain, 74% of the emissions are indirect from fuel consumption to run refrigeration equipment, while 26% are direct from refrigeration leakage. Also, more than 70% of the direct emission are coming from retail, and 60% of indirect emission are coming from retail and domestic energy consumption. It's very important to remember that these numbers are only associated to the cold chain. So when considering the food waste at the consumer stage, as shown in the red bar, which are found, these are found to be very important and more important than that of the equipment itself, and much important than those emitted from food losses. So the consumer is found then to be the largest emitting source in the post-farm gate sectors, knowing that in Europe, about 20% of food produced is wasted. It should be also noted that food waste is separate from food disposal, which includes food waste, domestic and industrial use of water, and also incineration. So accounting for the waste or the waste disposal should be further explored, and emission sources classification will be obviously changed. And this is something that we will be looking at in enough. So to reduce emissions, there is a need then to raise consumer awareness about good practices to reduce food waste, also reduce direct emissions, adopting natural refrigerant, and also reducing indirect emissions through an increased system efficiency as applying thermal integration, thermal storage. And all these aspects will be covered by enough project. Thank you very much.
Thank you very much, Yosr, for the presentation. Again, striking figures, and hopefully that will help raise awareness within people, consumers' behaviors, but also all industries and all segments, sectors. I would like to now call Judith Evan from the London South Bank University on opportunities for reducing carbon footprint from food chain.
Apologies, it takes a little bit of time to get the presentation ready. So hello everybody, let me just get a nice pointer. I'm Judith Evans from London South Bank University. I should stress that although it's my name on the presentation, that the work I'm talking about involves 14 of the partners within the project, including us. So it's quite a big piece of work involving a lot of other people as well. So this is the work which is looking at technology roadmaps. I just wanted to start by just framing where this stands within the project, because the project is quite nicely linked with all the initiatives working together. So the roadmaps work directly feeds to and from the baseline and future projections work that Yosr has just talked about. but also it feeds into the integration tools work. There's a very nice part of the project which we're not necessarily presenting today in too much detail, but is looking at modelling across the whole of the cold chain and integration. There's also smart data, which Kristina mentioned, the demonstration activities, which Silvia is going to talk about a little bit later, policy, consumers and business, and obviously communication. And the roadmaps sort of feeds into all those, and all those initiatives also feed back into the roadmap as well. So for example, you know, we might be able to identify some good demonstration activities, whereas the demonstration part may be able to feed some really good information back into the roadmaps. So what will we actually cover in this part of the project? The aim is to create roadmaps for different sectors of the food chain. And so we're focusing on major food groups and the emissions. So we're looking at foods in terms of things like meat, dairy, fish, fruit and vegetables, bakery and beverages. But we're looking at technologies. And when I say technologies, we're looking at both the technological options and also the operational aspects as well. So it's not just technology. And the aim is to look at how we can reduce greenhouse gas emissions across the whole of the food chain. And when I say the whole of the food chain, that's from harvest or production or slaughter through to the point that the consumer eats the food. And we're not just looking at refrigeration as the work that Alan was talking about. We're now looking at cooling, heating and HVAC as well. So we're looking at a lot more than we did in the UK projects. And the idea is to identify the reduction in greenhouse gas emissions and carbon reduction measures, but also to assess the cost and the time for application. And so one of the things that we probably can't do is split those individual food groups across all sectors of the food chain. So for example, in this figure here, showing the different types of foods we have here. Let me just put my pointer back on. And the different sectors of the chain. So we're going from processing through storage, transport, catering, retail and domestic. So once we get into storage, the food gets pretty much mixed. And so we probably have to consider all products together. Whereas in processing, it's quite often that they're different. For example, you would have a slaughterhouse for meat, you know, a dairy processing plant. So it's possible that we can split the products in processing, but probably not once we get further down the cold chain towards the consumer. And so the initiatives within the project, there's three major initiatives here. The first thing that we've done is develop a model specification structure. So basically it's identifying how we'll do this work and how it will work within all the partners that are involved in the project. The first thing is technology reviews. So we're reviewing those technologies and initiatives that can reduce greenhouse gas emissions. And I'll explain a little bit in a minute, a bit more about what we're going to do. We also need to be able to create those roadmaps. So we can look at what the technologies and initiatives can actually do, but we have to identify how they work together and what the potential is. So we're using case study sites from different sectors, which will then model, and we'll be able to look at the impact of those technologies on those case study sites. And from that, our aim is to create different roadmaps to be able to see where people are on the journey through to reducing emissions, and to see maybe what the next step is in that pathway for them. So in terms of the assessment of the technologies and measures, we're assessing the technological and non-technological. So we're looking at operational behaviour measures to reduce emissions. And we're looking obviously across the whole of the cold chain. One of the things is you have to be very clear on the boundaries that you're looking at. The first sector we're looking at is supermarkets. And you can see a rather simplistic diagram here. And so we've got to be clear that we're looking at the building of the supermarket itself. So the building envelope. We'll exclude things like food service and cold stores because they come into other sectors, but we're definitely looking at the display cabinets. We're definitely looking at the hot cabinets in the store. We're looking at lighting, people and infiltration. We're looking at the building itself. And we're looking at the HVAC systems as well, whether that's heating or cooling, which may be different in different parts of Europe. And also looking at the non-public area as well. So you've got to be quite clear on where our envelope lies. And the idea is that we will critically review the information on the technologies and non-technical aspects. We'll assess what information is available, how much it costs, how long it takes to apply. And so from that will help us create those roadmaps. I talked then, the next stage is the case studies and the modelling. The idea, if possible, is to identify 2 to 3 case studies from each partner country involved in the work package per sector. We need quite a level of detail to be able to enable the detail we need in the modelling. But we need to really be able to assess what the impacts are of applying different technologies in different regions over different seasons and the interaction between technologies. I mean, for example, I've tried to show some of the nuances across here. So if we have carbon emissions, this is reducing emissions, that's increasing emissions. So for example, if we put doors on cabinets in supermarkets, it would save carbon emissions. I don't think there's much doubt about that. The level may be open to debate, but we will save carbon. But on the other hand, in some locations, if we're no longer cooling the store by having open-fronted cabinets, we might then have to provide more cooling through the store via the HVAC system. But that only may be in some countries in Europe. You know, also we may apply a refrigerant. It may use more energy, but it will have less emissions, for example. So, you know, there's always impacts. We could reduce the store temperature, which would reduce energy and reduce, but that might actually take some energy to do that. We'd reduce the energy of the cabinets by doing that. And maybe we could do this store reduction by using free cooling, for example, which may be a really low GWP, a low carbon emission scenario. So the idea is through the modelling using a building simulation model is we're going to be looking at these interactions and also the impact of adding several interventions, you know, because for example, you can't assume that intervention 1 will have each intervention will have an impact, and we can't assume that individually those impacts can be added together. When you add them together, when you add more and more measures into the equation, they have less and less impact. So we've got to look at the interactions between them as well, and we can only really do that through a modelling. From that, we'll create roadmaps. They'll be based on carbon, energy saving, cost and time. And we may have to create different roadmaps for different locations in different countries. But the idea is that through these roadmaps, users will be able to identify where they are on a decarbonisation pathway and see the next steps that are appropriate for them. So not everybody may, for example, in a supermarket, have the absolute best technology that's available today, but people can see what the next step might be for them on their journey down that road to decarbonisation. So that's really just a quick run through what we're going to do. We're just starting on the work on the retail, and then we'll be moving on to other sectors. The next one that we're dealing with is food service and then food storage. And so if you'd like any more information, please do get in touch. I'm very happy to give you more information on this initiative. So thank you very much, everybody.
Thank you. Thank you, Judith, for the
Okay, we seem to have lost Julie there. I think we've got a little bit of a problem with her internet connection. So I'm going to introduce our next speaker, which is Silvia Minetto, and she is doing a talk on smart new technologies for the food chain. So Silvia, would you like to just turn your mic on and put your camera?
And good afternoon to everybody. So I'm going now to present you some smart technologies that we believe that can help within the project, can help to decarbonize the business, the food sector. And in particular, I will focus on some demo cases that are already ongoing within the project. So as Kristina has already described, INAF is going to demonstrate promising technologies to decarbonize the food business. And we have, based on our experience with the help of stakeholders, we have identified some key products and some chain links. They have been identified since the beginning. And so we have started a project having in our hands already a portfolio of technologies and demo cases that we believe are worth being tried and demonstrated to show how we can help to decarbonize the sector. New opportunities, as Kristina said, new opportunities will be identified, and this will be an outcome of the other activities of the project. For instance, what Judith has just described. So we will have the opportunity to demonstrate and to promote and demonstrate some other technologies, and this will be also done to fill some gaps that we still have in our demo cases. We have some, let's say, core technologies or core groups of technologies. We know that in the food business, we have different thermoflows. We sometimes need cooling, we need heating. Sometimes this happens at the same time, and sometimes it doesn't. So we need to exactly know, and we know exactly the thermal flows involved in each process, and we need to know if they are needed at the same time, or if we need to put in place, for example, thermal energy storage. Sometimes the temperature that the energy flow that we can recover from a process, for example, has not the right temperature level. So high temperature heat pumps have been identified as a key technology for increasing the temperature level of the waste heat, and to work towards the limitation of the use of fossil fuels. We know that we have also to work together with the grid, so we need to integrate our activities with the grid, and especially when we are using renewables. So we have a first big family, which is optimization of energy that I've called optimization of energy flows. Then if we want to pursue sustainability in the long term, we know that we need to use fluids and materials that will not have any impact towards the environment, not today and not even tomorrow. So we need to use natural working fluids and materials which are sustainable in the long term. So sustainable, I would say, forever. So we have a second big family, which is use of sustainable fluids and sustainable materials. And finally, we have seen that food waste is a big problem for emissions. So for sure, we need to improve our processes. We need to improve freezing and to improve cooling. And these processes need to be efficient on one side, but also to promote the quality of the food, so that we can preserve food in a better quality and for a longer time, so that we can avoid food losses. So these are the three big families of technologies. And now I will try to show you how we are going to demonstrate these technologies within the project. This is the metrics that Kristina has already shown in the first presentation. So we have some key products. Let me select my pointer if I can. Here it is. Okay, so we have some products that required specific handling, like meat, fish, dairy, fruit and vegetables. And then we have some the links of the chain of the process, storage, transport, and the retail and domestic, which means the domestic refrigerator. Within this matrix, we have these dark gray boxes where we have already identified since the beginning of the project some demo cases. It's the case of meat, of milk, fruit and vegetable, of transport, storage, retail and domestic. We will soon fill out also these other boxes like fish and like storage, so huge facilities for storage of different types of foods. But we still have some open boxes like others. We have this big family we called others because we have seen in the previous presentations that we have other sectors that are highly energy demanding, like, for example, beverages and cooking, baking, and so on. So there is room for other demo cases. We are still missing 6 of them. So I will now go into details to show the demo cases that are now running within the project. And please keep in mind that you can find these details about each of these cases in our website, and you can also find contacts of people of the institution and the leading partner for each of these demos. We have, for example, this high temperature heat pump, which is intended for meat and can produce steam at 150 degrees. It's combining absorption and vapor compression cycle. It can provide cooling and heating, and it is suitable then for the replacement of fossil fuel boilers. We need also to keep in mind that we are now, trying to demonstrate each of these technologies within a specific sector or product. But one of the goals of the project is also to try to find synergies and to see which of these specific technologies can be exported to other products or other links of the chain. So this is also one of our activities, to try to see integration and synergies between different sectors and products. Dairy is also well demonstrated within ENAF. This is an example of what is going on in Austria. It's dairy processing normally requires cooling and heating, for example, for cleaning in place or in general terms, hot water. And this system is based on natural working fluids. It's based on ammonia, and it's integrating a chiller with a high temperature heat pump, which is upgrading it to 90 C. And this heat is then used to partially replace the steam demand of the site. We have another dairy processing site in Norway, where we are not still using a natural refrigerant, but this time it's CO2. So we have 4 parallel units that are producing cold and hot, and the recovery of the waste heat is used for cleaning place and for domestic hot water production. We have also an optimized storage system just to decouple the heating and cooling demand. This demo is dedicated to fruit and vegetables, and it's dedicated to improving the storage quality of the storage conditions for fruit and vegetables. It's a dynamic controlled atmosphere system which measures the oxygen level in the storage rooms and optimizes the oxygen level so that the quality of the food is maintained. While maintaining the quality of the product, the fruit, we the cooling demand is lowered, and in this case we are expecting an energy savings which is ranging from 10 to 20%. So in this example we can see how the quality storage conditions and energy efficiencies, they are going together. This is again another demo for fruit and vegetables, and it has to do with materials in this case. So we are trying to use only sustainable materials for packaging, and this is a very specific application because we are dealing with soft fruits, berries, and in this specific business sector, the food loss is the major economic loss. So packaging is has the greatest importance. So we have sustainable packaging, which has to assure the quality maintenance of the product. And finally, just to few words about transport. We have seen that transport is responsible for a lot of emissions. And in this very last period, we have seen how the importance of short distance transport, so the last mile delivery, has increased due to the COVID pandemic. The idea is to combine natural refrigerants, so refrigeration cooling units for working with natural refrigerants, in this case is a CO2, with you can see on the top of the truck PV panels, so with the use of renewables to reduce the emissions. This can be also combined with hybrid or plug-in electric trucks to further decrease the environmental impact. And this can be intended in an absolute terms, but also in terms of avoiding any localized emission and noise when working, for example, in city centers. So these are examples that you, as I said, you can find in our website with all the details and also the contacts, but we have more on the way. So we have other demo cases where we are displaying smart technologies for the decarbonization of the food business. We are working on optimized display cabinets for retail, where we combine thermal energy storage and demand side response. We are working with domestic. On one side, we have domestic, the improvement of domestic refrigerators, so some kind of how to say, combination of a traditional way of storing food with advanced technologies like variable speed drive and electronic expansion valve. On the other side, we have also different approach. For example, we are proposing long-term storage with vacuum freezing, also done at home, which is not typical of the domestic market at this time. So also, let's say, an innovative approach to storage at home. And we have some new demonstrators planned. Optimized heat recovery from large refrigeration systems. We know that heat recovery is a key technology for using waste heat and for decarbonizing the sector. And in addition, this technology, we have other demonstrators that are coming soon, and they are mainly working on energy efficiencies and processing quality of products, like super chilling for longer and better quality storage, brine freezing for fish processing, so for achieving a faster and a better, faster process, so less energy consumption, and at the same time a better quality of the product, so with the longer storage and higher, better market opportunities for this product. And blast freezing with CO2 direct expansion systems. And as I told in the beginning, we are still open to more demonstrators that need to be identified in the next coming months. Thank you very much for your attention.
It is now the time to invite our panelists for an open discussion on the topic of carbon footprint reduction. We will welcome on the floor, on the virtual floor, Mrs. Andrea Voigt, who works for Danfoss Climate Solutions as the head of Global Public Affairs, and she's a member of the Strategy and Sustainability team. We will also have Brian Churchyard, who's the head of Engineering, Net Zero and Energy at ASDA. We will have Shane Brennan, who is the CEO of the Cold Chain Federation in the UK, an experienced lobbyist and campaigner. And we will have Mrs. Melanie Jans-Singh, who is the Senior Technical Energy Advisor at the Department for Business, Energy and Industrial Strategy at the University of Cambridge. Welcome, everyone. I hope you all enjoyed the presentations and have some ideas on the topic. I would like to trigger a first question, maybe, looking at the reality of the market today and the, let's say, the consequence of the COVID pandemic with a tremendous rise of the e-commerce. Is this rise of e-commerce contradictory with the efforts to be more carbon neutral, or is it an obstacle to it? And so how can the industry react to that market trend that is pushed by the consumers?
I'm happy to speak to that. So ASDA is a large UK-based retailer, and certainly to the question of the pandemic and the impacts, and the increase in online activity was significant. I think growth occurred within a matter of months, versus a 5-year plan of growth was achieved within a matter of weeks, if not months. What that's created is a requirement for additional cold chain requirements within the business. So additional cold room space, frozen food to be able to support that operation. Utilising as best we can existing equipment that already exists within our superstores. But because the growth has been that rapid, it has required us to put additional systems in place to be able to cope with demand. So therefore, what we're effectively looking at is against the backdrop of more equipment means more fugitive emissions and greater energy consumption, and trying to find ways to offset that is challenging. But I guess the change of shape of supermarkets will also change over time as we see that growth, and innovation will start to kick in further to try and understand what the best way to operate these buildings are.
Thank you, Brian. Anyone else from the panelists would like to react on that? So how realistic is it to achieve the net zero by 2050 with those, market developments that cannot be anticipated maybe or monitored?
Well, I'm speaking on behalf of BEIS. So for those who don't know, in the UK is the Department for Energy and Industrial Strategy. The challenge with a big change in market, in how the market is organised, is we lose the evidence behind making policy. So although this doesn't make it impossible to get to net zero by 2050, of course, this has to come with a big data collection system and monitoring system to understand what impact that has on emissions, so then policy and regulation can follow in an evidence-based way.
I'd like perhaps to add something, coming back to what was said earlier in one of the presentations on the Scope 1 and the Scope 2 emissions, which really put the finger on something which we have known for a long time, of course, already, but which now, with all these science-based targets and the need to collect and measure the data as well, is even more, I would say, at the forefront of concerns regarding that. On the one hand side, we have the refrigerant-related emissions in the Scope 1, with the global warming potential obviously playing an important role. And on the other hand side, we have the energy-related emissions. And here, and I think the current crisis as well in terms of energy makes it even more evident that we really have to decarbonize the electricity generation. And as we decarbonize the electricity generation, we will see more renewables coming into the system. And as we see more renewables coming into the system, it will be extremely important that we can provide the required flexibility to cope with this intermittency of those energies. And I think there, and it was also said in I can't remember in which presentation, but it was said several times actually, there our sector can also make quite a big contribution, because we have that possibility to also integrate different sources and make sure that, for example, we use the waste heat from the cooling in an integrated way and not just look at silos. And I think what we really need is the right framework to make this happen, or to support this integrated approach, rather than just looking at the cooling equipment in isolation and at the electricity generation in isolation, but really bring it together. And if I look at legislation in that respect, if I take as an example the recast of the Energy Efficiency Directive, which we see at EU level right now, there are opportunities in that sort of policy measures which really can support this, such as, for example, a mandatory energy planning to make sure that these energy needs, so where does the energy occur, where is it available, where is it needed, to really bring it together and make sure that those synergies can be used in the most efficient way. And that would then in turn help, to come back to what I said in the beginning, that would in turn help to decarbonize the electricity system, and that in turn helps then to also reduce the indirect emissions next to energy efficiency, obviously, which is the other big thing, and which goes hand in hand, basically reducing the need to produce that energy in the first place.
Thank you, Andrea. And obviously, it's not only cold chain operations and refrigeration equipment. When we talk about e-commerce, it's also about packaging.
It's everything, yeah.
So it's a holistic approach, and there might be some challenges to have all the different players working hand in hand, collaborate together towards that, common effort. Shane, any views on your side?
I think totally a fascinating set of presentations and some really great contributions already. I guess Andrea is really sort of hitting the key point for me, which is the interrelated nature of net zero targets for different actors. And my scope 1 emissions is your scope 3 emissions, and vice versa, and so on. So I guess that on the positive side of that, everyone's got the same kind of overarching objective: do more with less, use less. And find ways to use less within the scope, within the terms of what you currently do. Whether that on its own, though, if you just take it the aggregate of everyone trying to get to net zero or trying to get to zero emissions, that doesn't achieve overall net zero, because there will be trade-offs. By one actor trying to get down to zero, they're going to start to palm off problems and issues into other parts of the supply chain. So the absolute key thing is the ecosystem. Is how do these interrelate to each other? Where's the transparency of information, and where's the shared goal and the shared goal within the system? And actually, I think something like the growth of e-commerce is actually a neutral point. I don't think that is in any way a driver one way or the other, because ultimately there's trade-offs there. So the question then is how do we create the platform for shared understanding of what the end goal is? And do we do that at the government level, so like for the whole of the UK, in my case, or do we do it at the supply chain, so farm to fork in a linear way, or do we do it in some other way? And I think that's probably still pretty unclear. And the more we talk about it, the more complex we make it, rather than necessarily we find clarity. But nonetheless, start from the first point. If everyone shares the same objective and buys into that objective, then we go a long way towards our goal. Whether we ultimately achieve net zero or not is a secondary point.
Thank you, Shane. Another point now, do you feel that financial investment that's needed to be more carbon neutral today hampers some industry players to move faster towards reducing footprint? And in this case, should there be more incentives from governments?
Shall I? Oh, I'm sorry, I know I just finished, but I'll go. I mean, absolutely. I think there's a big difference. So one of the questions we have at the moment is government policy, certainly in the UK, is very focused on R&D. Finding the next widget or gizmo that's going to transform the nature of a process. And yes, if you there are times when you do that kind of investment and you discover something, or you make something come into existence that didn't exist before, that will transform things fundamentally. I think now, sort of 4 years into talking at cold chain, I don't think we know whether there's not the known unknown of the gadget or gizmo that's going to transform things fundamentally. So it is about marginal gains and incremental change. So then if it's not about that, then it's about getting operators using better, more efficient systems. And that involves cost, particularly if you're talking about a refrigerated warehouse, or you're talking about an operator operating fleet. How do they make up the gap between what currently costs, £100,000, but is going to cost £150,000 with the greener alternative? How do you make up that shortfall in the cost? And currently, UK government policy really doesn't go into that area at all. In fact, if anything, it's an actual move against doing that. And that then creates a barrier for businesses like myself. We're trying to advocate businesses to do the right thing, in inverted commas, and spend more money up front to do the greener or more efficient technology. But they just don't have the business case for that. So how we find the shortfall between those two things, I think, is really important. If you look around the world, the most advanced places, or the places that are seeing the biggest acceleration in change, are putting those financial subsidies in adoption, into technology adoption, to make a difference.
Yeah, I'd echo what's been said there. I mean, as a cost-sensitive retailer, we are able to deploy low carbon solutions through energy reduction. That has to be proven absolute in terms of any investment that's put in place. The other thing is part of those measures is doing something over a life cycle benefit in terms of what those measures are. So not just looking at the immediate quick fix, but what does it mean long term in terms of the application investment of that technology? Because when you look long term with a long term lens, you're not just taking the financial benefits of the energy savings, which then will obviously bring into it carbon savings, but it will also bring the carbon tax benefits, which will be inevitable in the future. So you end up with two financial benefits for an initial upfront capital investment through energy savings, kilowatt hours reduced of the pounds you're paying for or euros that you're paying for energy, as well as the decarbonisation of national grids that will revolve around that. But equally, you will take the benefit of those carbon emissions reductions over time. So, and it's also making that technology of the future, which was explained there, we're still trying to figure out what that is. The more affordable it can be, the more of it can be done and the quicker it can be done. But I don't think it's necessarily one solution will fit all. We're talking about a toolbox of solutions here, but you can't speak to carbon and energy in isolation. They have to go hand in hand in the same discussion.
Yeah, definitely. And adding to this, perhaps also what would be needed is to further valorize, for example, if I'm coming back to what I said previously on the integration of sectors, to valorize, for example, if waste heat is being reused, so that it becomes an incentive and not something which has no value for those who reuse the waste heat. Because right now, why would you do that if you don't have a direct sort of something which is beneficial? That's one, and same goes for flexibility. If you can offer flexibility, for example, as a supermarket, if you can offer flexibility to a grid operator, or what are you getting in return? To what extent is this interesting for you? So why would you do it in the end? I think that goes very much back to the business case and to the business model, which we need to make those things happen. And also perhaps the third thing I wanted to mention is the ESCOs, like service-based business models, where you would take away the initial. Sorry, I got a message which came in the middle of my screen, which distracted me. So, is our service-based business models, where you would take away the initial investment cost, and where you would then pay as you use, or pay for the service, or pay for the cooling or for the heating that is required. Maybe that's also a way to further incentivize and create business models to make those things happen, aside from easily saying, well, governments just need to put rules in place and need to force people, which in itself will unlikely be enough. It's really creating the entire business model around it to incentivize those things.
Yeah, so just to add on to what you said, I agree with all of you. So coming from a government perspective, the funding so far has been mostly around innovations and funding innovations. And I can give two examples of recently funded by BEIS projects supporting demonstrator of efficient systems, cooling systems, or new cooling systems. And I think that it has been, and the IEA has declared in 3 reports in a row, 2018, 2019, 2020, that cooling has been a policy blind spot. So it's potentially that has been a bit of an overlooking to that sector, but that's not for no reason. It's also that cooling was 2% of UK greenhouse gas emissions, whereas heating was a much larger share of emissions. And so the focus has been on the bigger size of the pie. But obviously, now that we've got net zero targets, everything is being looked at, including harder to abate areas. But also another reason is that the TRLs, the technology readiness levels, are quite low. And so many reports have shown that even though it's very hard to reduce cooling emissions, and the trade-offs, as have been mentioned in all the presentations, are quite complicated to determine, and they're not known yet. So we know that packaging will be a net benefit, but to what extent would it be? I thought the EU presentation was really interesting as well, to see how there's a shift in terms of the size of emissions of the cold chain compared to the food production. But now that this is also a relatively new process, and so things are changing, and obviously, and as you've been saying, as there's so many different areas at which we can reduce our emissions, not just energy systems or the efficiency gains, but also packaging. It's difficult to make an overarching policy given how policies are organized in different areas. So yeah, so it is difficult, and it's something, as you said, we all have to work towards together. And I agree. So for example, we're talking about the waste heat recovery and integration of systems within BEIS. This will fit within heat networks policy making, whereas other types of efficiency will come from different policy angles. So yeah, anyway, just trying to provide a different perspective here.
Thank you very much, Melanie. Always good to hear the government perspective indeed. We know there are still some paradoxes out there. Just to give an example, we've talked about a lot cold storage, but refrigerated transport is another main key sector where carbon footprint is pretty significant. And when you look at the mobility package, the EU mobility package that forces somehow drivers to get back to the home company with empty trucks, it's a little bit paradoxal to what we should do to, be more sustainable and be more efficient in terms of energy usage.
Exactly, but on this actually, it always comes back to data. I think now that we have better ways of gathering data in real time, and even that has its challenges today. We're not at a point where we can just put sensors everywhere and get reliable data. But knowing how many transport refrigeration units there are, how much energy they're using for cooling is something that's actually not known today. So trying to make something to improve this is still a challenge given where we're at. I think sometimes we wish we were further ahead of what we know than we are.
We've got some great ideas on that, Melanie. I'm sure you've seen them before. We'll send them again on how we get that data into a better place in the UK at least.
Yeah, we know data is a crucial thing that everybody's looking for, but nobody's willing to share. Shane, do you feel like there is a shift from industry to be more open to sharing data with those, big objectives and changes?
I think there's definitely a big shift. I think everyone is, I think the biggest cause for optimism is how sort of commercial attitudes are shifting towards understanding the shared goal around these issues and starting to take some of the data points that would have traditionally been completely seen as completely commercially sensitive to realizing and challenging that and saying, actually, these aren't that commercially sensitive, and actually, whether it be through a direction of travel around government forced transparency or just generally understanding that there is that opportunity to learn by sharing on some data points is really good. But I think we are still up against that one fundamental barrier to this, because ultimately these are about ecosystems, I said it before, of collaboration between commercial actors. And we're still in a place where ultimately the commercial interest sits as the paramount in the situation. And therefore we do have fragmentation of visibility of what's happening to a product as it moves through a supply chain or the like. And so I think that probably the single biggest innovation area isn't the piece of kit, isn't the new refrigeration system, it isn't the new vehicle. It's going to be that data, that way of gathering and sharing data across platforms, across commercial actors, that probably is the key to net zero, in my view.
Yeah, exactly. Exactly. And I think the power that we have with with digitization and all the technologies and remote monitoring and sensing, and I mean, there is really a super wide range of technologies and possibilities in order to achieve that. But to really bring this to success or to fruition is also difficult because of what you were just saying, Shane, because of this fragmented nature of this sector. And that fragmented nature is also the reason why it's not getting the attention probably that it is that it should get, because you have all these parts which are somehow related. It's super complex, the cold chain, and as soon as you start digging into one thing, you will see that it'll be related to another thing, and there is this lack of a coherent approach and collaborative approach of the different stakeholders together. And I don't have a solution to that, but it resonates very well with what I wanted to say as well. But perhaps with the digitization, we really have a tool or a vehicle to make this happen in terms of platforms and in terms of sharing and bringing those different fragments together.
Thank you. We are almost at the end of our session. Maybe a last question to close this workshop. Do you have a view on what Enough and other similar projects should concentrate on? Are there specific sectors of the food chain or types of carbon emissions that we should focus more on?
I think it was just mentioned there that without the data, you just have opinions. And it's as simple as that. I think without the data is the start point benchmark of everything. So if there's an opportunity to influence and harness, capture more efficiently all of that information, then it really gives you a great starting point.
Thanks, Brian. Yeah, some data points were pretty striking and somehow disturbing, especially for me representing the cold chain sector, cold chain logistics, and to see that the level of emissions for storage was so low compared to others. It got me to wonder whether it's an issue of data sourcing or lack of data, or is it the reality?
I think, to answer your question, Julie, I think it's both. I think there is, the data isn't great in lots of places, or at least it's certainly not very comparable between different sources. So coming up with a better way of understanding the data would be really good. I guess if I had a research question, a hypothesis for testing that I think needs more attention, is the issue of how we, and I think it does play into this idea of the ecosystem, is how are we gathering, how are we measuring and maintaining the right temperatures through the supply chain? And often we think about the right temperatures through the eyes of food security, in the case of food. So how do we make sure we never go above a certain point, how we maintain integrity of product through the chain? That, I think, often leads to over-chilling and over-cooling. And I think that if we had a different, I think a net zero world, surely the environmental impact of what you're doing with that to that product is as important as the food security and how you address those two things. So I think understanding the challenge of end-to-end product monitoring through a chain, I think, and understanding how you do that, how commercial actors could do that in the right way, I think is probably the question that I would be most interested in understanding research on. I know there's been stuff on that at different points, but I think we can take that one on even further now.
Thank you, Shane.
Yeah, and I would support that and add to it perhaps that the role of digital solutions in that respect in order to make that happen. I think that would be really very useful to dig further into.
Thanks, Andrea. Any other closing word from Brian and Melanie?
I'll just conclude by saying I thought it was very interesting how all the products have been broken down by product type and across the chain. And understanding the trade-offs between these different food types and elements can help focus policy making towards the most efficient or the area with the most impact. That would be very helpful in the first instance. And secondly, to use data and present data with uncertainty ranges so that policymakers have an understanding of how certain we are and understand our certainty levels today.
Brian, any additional word?
Just the final piece around when we speak of direct, indirect emissions and energy needs to be spoken in a collaborative way, not in isolation from each other. They're all as equally important as each other. Reducing one could have a negative impact on the other if we don't look at it holistically.
Very good. Thank you very much, Brian. Thank you all our panelists and presenters today. I think it was a great light shed on this very interesting and still not very known topic. I'll probably call Lisa to do some housekeeping before we close.